Very good morning, friends. Today we will see the very last problem in engineering mechanics, and that too the second problem in the collision of elastic bodies. Right? This is the oblique impact problem we are going to see. So you see the problem. The problem is like this. The problem: two identical smooth balls. Two identical smooth balls means its mass are same. So MA, MB is equal to M. So we can keep it as M. That is the two identical balls. And these balls are hitting, it is moving in 20 meter per second with a velocity of 20 meter per second at an inclination of 30 degree to the horizontal. And the second ball B is moving with 30 meter per second and 50 degree to the horizontal, it is inclined. So this is both are inclined manner, it is moving and it is hitting at one point of time and it will be going outwards after impact. Okay. So what is the velocity? If the coefficient of restitution is 0.6, in your problem it is given. If the coefficient of restitution is 0.6, what is the final velocity of the body is after oblique impact? So you have to find out the final velocity. How to solve this problem? First of all, this is an inclined velocity. Okay, we can resolve it into horizontal component and vertical component. Similarly, this I can resolve it into horizontal and vertical component. What is the horizontal component of this? It is positive. It is 20 cos 30. And what is the vertical component? It will be 20 sin 30. This horizontal component will be 30 cos 50 and vertical component will be 30 sin 50. That's what I have written here. You can see here in this body A and body B, I have resolved into two components. First component is 20 cos 30, that is horizontal component, that is 17.32, and this vertical component will be 20 sin 30, it is 10. Then similar to body B, it will be the horizontal component will be in the negative direction, that is 30 cos 50, 30 cos 50, and its value is 19.28 in the negative direction, it is moving, right? So minus 19.28 you have to give it. Then the vertical component of body B will be 30 sin 50, that is 22.98, it is a vertical component. So now what we have to do for this impact, which component will use for this impact, okay, which component will be the reason for this impact is the horizontal component. The vertical component, due to the vertical component, it doesn't have any impact. It will be going, moving, keep on moving on the vertical direction. So due to the horizontal component, it will have an impact. So that horizontal component, we will take it and we will resolve it similar to the previous problem. We will find out the final velocity of the horizontal component. So final horizontal component, we will find it out. So you can see in this one, the conservation of momentum equation, you have MA UA plus MB UB is equal to MA VA plus MB VB. So why I have strike the MA MB MA MB? So all are M. Okay, all are same mass, having the same mass. So I can strike it out by M. Okay, so I will getting it as UA is 17.32 minus UB as 19.28, that is minus 19.28. It is not positive, it is negative. The second ball is moving in the negative direction. So I have taken minus 19.28 is equal to VA plus VB. So my VA plus VB is equal to minus 1.963. It is my first equation. Then using the coefficient of restitution equation, that is 0.6 is equal to Vb minus Va by Ua minus Ub, that is V2 minus V1 by U1 minus U2. That was the equation. So you have the Vb minus Va and Ua is 17.32 and Ub is equal to minus, so minus is for the equation and this minus is for the negative direction of the velocity, minus 19.28. So it will be plus. So I will take it to the left side. So it will be Va minus Va plus Vb is equal to 21.963. This is my second equation. So I have one equation, two equations. Second equation, first equation and second equation. The unknowns are Va and Vb, Va and Vb. I can solve it for two unknowns using my calculator. I will get Va as minus 11.963, Vb as 10. So Va is moving in the negative direction, minus 9.63. Vb is moving in the positive direction, that is 10. Sorry. Right. Okay. So you can see the second um, equation. So after impact, the horizontal component VA will be minus direction, that is 11.93. Horizontal component of the B will be positive 10. Right. So what is the vertical component? The previously what we have resolved in the original problem, what we have resolved, that is the vertical component. This is positive 10, this is positive 22.981. So you have got two components after impact for each ball. You have got two components. Now, how to find out the resultant of each ball, which direction it will move and resultant. So, this is horizontal component, this is vertical component. You can take the square root. You can square this and you can square this and sum it up and take the square root. You will get the resultant. That resultant is 15.592 meter per second, that is the velocity. And similarly you can take the square of this and sum it up and take the square root, that is 25.062 meter per second, that is in the another direction, this direction, and this will be in this direction. The ball after collision, it will be moving in this way. It will be moving in this way, right? So what is this angle? What is this angle? How do you find out something in the very first unit? How to resolve the problem? How to find out the resolve the forces and how to find out the resultant and how to find out the angle? Angle will be alpha is equal to 39.9 degrees and beta, this is my alpha and this is my beta. Beta will be 66.48 degree. So this is how you have to solve the oblique problems, oblique impact problems. Okay, thank you.